Okay, so we're going to go over the Unit 3 test, and I'm going to go over each problem so you can fast forward to the ones that you missed or go over the ones that you need to go over in this video. Okay, so we're just going to start with number 1. So here we're looking at the change in position from the solid figure to the rotated figure, or the solid figure to the dotted figure. And in this case, this guy is a rotation, but in order to really tell that it's a rotation, it's really helpful to look at two corresponding points. So for example, the coordinate of this point is -3, 1, 2, 3, 4, 5, 6. So that coordinate is -3, 6. And then if you look at the corresponding point, which would be right down here, its coordinate is -6, -3. So in this case, the transformation has been xy has been mapped to -y x, and that's a rotation of 90 degrees counterclockwise about the origin. Okay? Which of the following represents an isometry? So remember, an isometry is something that creates a congruent figure. It's a transformation that creates a congruent figure. So these two, not congruent. These two, not congruent. These two, not congruent. They're different sizes. So B creates two congruent figures even though one is turned. So B is the isometry. In number 3, a reflection is always which of the following? Well, it can't be a rotation because it's a reflection. It can't be a translation because it's a reflection. Reflexive isn't even a word that we've talked about. Isometry is the correct answer. Of course, if we reflect something over an axis, it creates a congruent figure, something whose sides and angles are exactly the same, and that's what an isometry is. Which transformation reverses orientation? Remember, this one was the reflection. So if I had a figure and we had, let's see, something like this where we had A, B, C, D, and E, if I reflected that over the axis, you can see that the orientation has reversed. Now I'm going in counterclockwise to name the points. A prime, B prime, C prime, D prime, and E prime. So here we're going clockwise. Here we're going counterclockwise to name the points in the same order. And reflection is the only one that reverses orientation. We talked about that a lot. Okay, so we want to find the coordinates of the image after we've done each transformation. So here we want to reflect in the line x equals 2. So the line x equals 2 is way over here. It's a vertical line. The other thing that we're going to do is list the coordinates of our points. So P is at -6, 0. S is at -6, -3. R is at -3, -5. And Q is at -2, -2. Okay, so we're probably going to need those coordinates. Whoopsies, didn't mean to do that. We're probably going to need those coordinates after to find the new coordinates after our reflection. Okay, so remember, to find a reflection, we want to look at the distance that each point is from the reflection line. So for example, the point P is 1, 2, 3, 4, 5, 6, 7, 8 units away from the reflection line. So I need to go 8 units on the other side of the reflection line in order to find P prime. So 2 plus 8 is 6, 7, 8, 9, 10. That's 8 units away from the line. So P prime will be at 10, 0. For Q, you can see Q is 1, 2, 3, 4 units away. So going over 1, 2, 3, 4 units away puts Q prime right about there. That's oops, putting that in the wrong spot. Put that down here. Q prime will be at 6, negative 2. Looking at S, again, S is 8 units away from the reflection line, so if I go 8 units away on the other side, it's also going to have an x-coordinate of 10, but its y-coordinate is going to stay negative 3. And then for R was at negative 3, so the distance from negative 3 to positive 2 on the x-axis, that distance is 5. So we have to go a distance of 5 from 2, so R prime will be at 7, negative 5. Okay, so those are the coordinates for the first picture. Let's see, that gets me S right about here, and that gives me R right about here. I can't connect them too good with this, but get some graph paper and that'll look a whole lot better. Okay, let's see if I can't copy these coordinates real quick and take them with me to the next. No, it's not letting me. Alright, I just want to remember our coordinates that we had to begin with. But it's not letting me move what I want to move. Weird. And let's see, let's get the other ones. Well, let's just write them down. We got P, S, R was at negative 3, negative 5. And Q was at negative 2, negative 2. Okay, so this one we want to do a translation under the vector 2, 3. Remember what that means is that every xy is going to become x plus 2 and y minus 3. So all we have to do is add 2 to each x-coordinate. Negative 6 plus 2 is negative 4, and then we subtract 3 from each y-coordinate. 0 minus 3 is negative 3. Same thing for S. So negative 6 plus 2 is negative 4. Negative 3 minus 3 is negative 6. For R prime, negative 3 plus 2 is negative 3 plus 2 is negative 1. And negative 5 minus 3 is negative 8. And negative 2 for my Q prime, negative 2 plus 2 is 0, and then negative 2 minus 3 is negative 5 for Q prime. Okay, so let's do the next one. This time we're going to do clockwise rotation. Let me undo that. Get my arrow here. We want to do a clockwise rotation of 90 degrees about the point 0, 0. So let's get our coordinates again. P was at negative 6, 0. S was at negative 6, negative 3. R was at negative 3, negative 5. And Q was at negative 2, negative 2. So we got to remember a 90 degrees clockwise rotation is given to us by the rule xy maps to y negative x. So that means P prime is going to be at 0, negative 6. S prime, or excuse me, 0, positive 6, because we have to take the opposite of our x value. S prime will be at negative 3, positive 6. R prime will be at negative 5, then reverse the x-coordinate, or opposite, so that will be positive 3. And Q prime would be at negative 2 and positive 2. And then, of course, you could graph these to see if they look right. So, like 0, 6 is up here, negative 3, 6 is up here, negative 5, 3 is here, and negative 2, 2 is here, and if you connect those nicely with the straight edge, better than I'm doing here, but if you connect those nicely with the straight edge, you can see it's got that clockwise rotation. Okay, the next one was the dilation with a scale factor of 1/2 centered about the origin. So remember, that means that my rule is, all these emails are popping up. This is ridiculous. My rule is xy maps to 1/2 x, 1/2 y. So p was at -6, 0. So p prime is going to be half of that. It's going to be -3. Half of 0 is still 0. S was at -6, -3. So S prime is going to be half of -6, which is -3, and half of -3. That's -3 halves, or -1.5. R was at -3. Let's see, what was that? -3, -5. So we just have to cut those in half. -3 halves, you might want to write that as -1.5. -5 halves, that's -2.5. And then finally Q was at -2, -2. So cutting each one of those in half, -1, -1. And again, check to see that it looks right when you graph it. -3, 0. -3, -3 halves, or -1.5. -1.5, and -2.5. And then, of course, -1, -1. And you can see that it has stayed exactly the same shape. The only difference is its size. Okay, the last one was a little bit tough because we had to do two things. We had to do a glide reflection. So first, we're mapping xy to x plus 4y, and then we're going to apply the rule. Since I'm reflecting over the line x equals 0, remember that's the y axis, that's going to be -x, y. So we have step 1, step 2. So P was at -6, 0. So step 1, P prime, is going to be at -6 plus 4, so that's -2, 0. Step 2 is going to be to reflect that over the y-axis, so that means the x-coordinate becomes opposite, so that's going to be at 2, 0. S is at -6, -3. So the first thing we're going to do is move that to the right 4 units, so that's going to be -4, -3. And now we're going to reflect that over the y-axis. That's going to be at 4, -3. R was at -3, -5. So first, when we move that 4 units to the right, -3 plus 4 is 1. So we start out at 1, -5, but then when we reflect that over the y-axis, it becomes -1, -5. And then finally Q is at -2, -2. When I add 4 to that coordinate, it's going to be +2, -2, adding 4 only to the x-coordinate. And then when I reflect that over the y-axis, it again becomes the point -2, -2. So all of these points right here are going to give you your final answer for your diagram in that glide reflection. In this case, it actually was like gliding and then reflecting that way. Okay, so number 10, if a figure is translated using the vector -3, 1, what vector translates it back to its original position? Well, this vector moves it to the left 3 and up 1. So if I had something that moved left 3 and up 1, and I wanted to go back to my original position, I'm going to have to go right 3 and down 1. So that vector would be represented by +3, negative 1. You just take the opposite of each of your coordinates. We worked with this a few times. A person is traveling in a car. This one's a little bit different. She goes 3 miles south, and then she goes 8 miles west. This time it looks this way. Now she realizes she's lost, so she goes 11 miles north. This is obviously not to scale, but my 11 is bigger than my 3. And then she goes 7 miles east. So I want my 7 to be less than my 8 when I draw it. We want the component form of the vector that shows me where she really went. Well, if this value is 7 and this value is 8, that means this little piece of my triangle is 1. If this up and down value is 11 and this up and down value is 3, that means this little piece of the triangle has to be 11 minus 3, which is 8. But since I'm going to the left 1 and up 8, in component form that would be negative 1, positive 8. And just remember to get your x values, your left-right values first, and your y values second. Alright, number 12, write the rule that tells me how to get from ABC to A prime, B prime, C prime. Please notice, ABC is down here. You got to start with the right pre-image to get your transformation in the right area. Another thing you might want to pay attention to is the coordinates. For example, A is at 1, 2, 3, 4, 5, 6, and negative 2. Where is A prime? A prime is at 2, 1, 2, 3, 4, 5, 6. But I can see that my two triangles have exactly the same orientation. A is on top, B is on bottom, C is on the left. So it hasn't been rotated. This is just a translation, and that's verified by the fact that it says translation in the problem. So what did I do to my x values to take me from 6 to 2? What do I have to do to 6 to get 2? Well, I have to subtract 4. Right? Now what do I have to do to my y values? My y values went from negative 2, I shouldn't have put that there. My y values went from negative 2 all the way up to positive 6. So what do I have to do to negative 2 to get positive 6? I got to add 8. So this is the rule for my transformation. You can write it as a vector if you like as well. Either way you're writing that is fine. Alright, number 13. The vertices of a triangle are this. Reflect it over the line y equals x. Graph the triangle and its image. So what I'm going to need is a graph here. I think I got one. Alright, so here's a graph. You need to start by plotting the points. A is at negative 2, 1. B is at negative 2, 4. And C is at positive 2, 1. So here's my triangle. We want to now reflect that over the line y equals x. You have to start with the right reflection line. The line y equals x, remember, whoops. Hello? There we go. The line y equals x goes like this. You might want to write down the rule. The rule for reflecting over that line is reverse the coordinates. So let's get a different color here. A prime will be at 1, negative 2, so over 1 down 2. That'll be A prime. B prime will be at 4, negative 2. That's here. And then C prime, reverse those coordinates, will be at positive 1, positive 2. That's here. So graphing the image and its reflection could look like this. And there is a little bit of overlap because the original figure overlaps the reflection line. Alright, in the hexagon, how many lines of symmetry do we have? We have to be careful here because notice that these sides here are longer than those sides there. So there's not necessarily 6 lines of symmetry. In fact, the only lines of symmetry we have are here and here because those two sides are longer. So the correct answer is 2. Tell if the figure has rotational symmetry. Well, we can see if we were to rotate this figure a little bit, it would land on top of itself. Remember that little thing where we draw lines that go out from the center and look at each different part of the figure. So we want to figure out what this angle of rotation is. We have to divide 360 by 3, and we get 120. So that's my angle of rotation. You could actually rotate it either direction, counterclockwise or clockwise, and it would still land on top of itself. Alright, so let's graph this using a scale factor of 1/2. One of the things about this figure, this one that made it a little difficult, is figuring out where my axes are. So I'm just going to highlight those so we can really see the coordinates. So for example, this coordinate here is 0, 4. If I cut that in half, I get 0, 2, which is right there. Over here, this coordinate is 1, 2, 3, 4, 5. 5. So if I cut that in half, I get 2.5, 2.5. That's right there. This coordinate down here in the corner is 1, 2, 3, 4, 5, 6, 0. If I cut each of those in half, I get 3, 0. It should stay on the axis. And this last coordinate here is 2, negative 1. If I cut 2 in half, I get 1, but if I cut negative 1 in half, I get negative 1/2. So that one should be below the axis. That was a mistake that several people made, was they plotted that point above the axis in the dilation, but it should be below. And there's my dilated figure reduced by half. Alright, so everybody had a really hard time with this problem. Let's see if I can get the whole problem on here. Might have to shrink this a little bit. Here we go. Given that line L is parallel to line M, the key to this problem, of course, is to draw a picture. So let's just begin. Here's line L, here's line M. We should label those so we can keep track of which is which. The distance between those two lines is D. So that means from here to here is D units. Now we know point P is reflected in L onto its image P prime. So we just start with a point, maybe we put it right here, point P. Now if I reflect that over line L, that means P prime would be right about there, right? And what has to happen is the distance from the reflection line has to be exactly the same. That's how we do a reflection. Then we're going to reflect that image, P prime, across line M, and that's going to create P double prime. So let's look at how far P prime is away from M. And we want to go that distance away, and now we're going to create P double prime, where this little piece is congruent to this little piece. And the question is asking me, what is the length from P to P double prime? And this is where the D comes in. The D is the distance between the two parallel lines. That's made up of one little red piece and one little blue piece. But notice the distance from P to P double prime has an additional red piece and an additional blue piece. So we know it's D units from here to here, but it's going to be another D units to incorporate that space outside the lines. So the total distance between those 2 points is 2D units. 18. Here we're graphing the line y equals negative 5/3 x minus 6. Then I am reflecting that over the x-axis. So remember, folks, that is this axis here. What would the new value of y be when x equals 0? So this is a really complicated way of saying what is the new y-intercept, right? Here, when x equals 0, y is negative 6. But if I reflect that line over the x-axis, 2, 4, 5, 6, if I flip it, my new line is going to look something like this. Okay, that was terrible. But let me get a real line here. 1, 2, 3, 4, 5, 6. My new line is going to be going down like this. All of my y values are going to become the opposite, and my x values are going to stay the same. So what that means is that the new y value when the x value is 0 is 6. It's just worded in a slightly different way. Alright, for number 19, find the value of x in the figure. Now, if you made a mistake in this problem, it was because you ignored this little angle right here. These two angles are congruent. That means this is also x plus 3. The three angles together form a straight line. That means that they all three have to add up to 180. So your equation should be x plus 3 plus x plus 3 plus 7x plus 3 equals 180. You also have to show your work on this, so I can't tell how you came up with your answer. So combining like terms, x, x, and 7x is 9x, 3, 3, and 3 is 9. So 9x plus 9 equals 180. We'll subtract 9 from both sides. We get 9x equals 171. And now when we divide by 9, we get our correct answer, 19. Okay? Label your figure. Alright, number 20, find the distance between these 2 points. So my distance formula is x2 minus x1 squared plus y2 minus y1 squared. And we want to take the square root of that. So x1, y1, x2, y2. So that's going to be 4 minus negative 5 squared plus 0 minus 5 squared. And I'm going to write the square root every single time so I don't forget to take it at the end. 4 and 5 is 9. 0 minus 5 is negative 5, but I'm squaring that. 9 squared is 81. Negative 5 squared is negative 5 times negative 5, that's 25. And 81 and 25 is 106. Now, I don't know what that is off the top of my head, but looking at my answer choices, the only one that makes sense is A. I know that a square root of 100 is 10, so it has to be slightly bigger than that. So 10.3 has to be the correct answer here. Alright, 21 and 22 go with the same diagram. What's the best name for line T? Well, it's a line, so it can't be a midpoint. It doesn't meet at 90 degrees, so it's not a perpendicular bisector, although it does cut AC in half. So that leads me to the correct answer that line T is a bisector. It bisects segment AC. Intersection is not the correct answer either, because you could say the intersection of those two things, of line T and segment AC, is point B. The intersection is where they meet. It's not a thing. Now, number 22 requires me to label my picture. If AB is 7x minus 22, or excuse me, 7x minus 2, and BC is 9x minus 32, we want to find the length of AC. Now I can see from my picture that these two are congruent. So 7x minus 2 equals 9x minus 32. We'll subtract 7x from both sides. And that's going to give me negative 2 equals 2x minus 32. Now adding 32 to both sides is going to give me 2x equals 30, and dividing both sides by 2 gives me x equals 15. Now, you might be fooled into answering B. The answer is not B because the question says find the length of AC. We have to plug that in. So, 7 times 15, I'm not sure what that is. I have to work it out. So that's 35. So that's 105. So 105 minus 2 is 103. But if this side is 103, that means this side is 103. And so the entire length of AC is going to be my 206. If you're showing your work on this and you answer 15, I can give you the partial credit. But if you don't, I have no idea how you did it. I think you just guessed and I marked it wrong. Okay, number 23. Name the intersection of plane M and plane R. So pay attention here. Plane R is going like this. Plane M is going like this. So if you look at those two planes, we want to know where those two planes meet. If you remember your postulates from the first unit, if two planes intersect, they intersect in a line, and you can see that that line is right here. The only 2 points we know on that line are T and Y, so my correct answer has to be line TY. 24. Find the midpoint of the segment with these endpoints. So you might want to write down your midpoint formula. Just remember it's the average of your x coordinates and the average of your y coordinates. Mark your points, x1, y1, and x2, y2. Plugging them in, it's going to be negative 7 plus negative 8 over 2, and negative 5 plus 3 over 2. Negative 7 plus negative 8 is the same sign, so we add and keep the sign, so that's negative 15 over 2. Negative 5 plus 3 is negative 2 over 2. And I know I can reduce that, that's going to be negative 1. But also looking at the answers, I can see I don't even have to divide 2 into 15. My correct answer is right here, negative 15 halves and negative 1. Alright, number 25. I think everybody might have got this one right. If the measure of EOF equals 28, let's label that. And the measure of FOG is 24, we'll label that. What is the measure of angle EOG? So EOG, that's the whole big angle. We simply add these two. 8 and 4 is 12. Carry the 1. 52 is the correct answer for number 25. For 26, in this figure, ray MO bisects angle LMN. We know that angle LMO is 6x minus 12, so we'll label that. We know that NMO is x plus 63, so we'll label that. And wait, we should label this piece too. It's been bisected. That means that these two angles are congruent. If they're congruent, that means that they are equal to each other. So here's my equation. Subtracting x from both sides gives me 5x minus 12 equals 63. Adding 12 to both sides gives me 5x equals 75. And then if we divide by 5, we get x equals 15. So look, you can eliminate these two answers. But we still have to go in and find angle LMN. That's the whole big angle. Now, when plugging this back in, I chose to plug it into this expression because it was easier. It's just x plus 63. So it's going to be 15 plus 63, which is 78. That means this angle here is 78. That means this angle here is 78. So the whole big angle would be 78 times 2, or 78 plus 78, which is 156. So D has to be the right answer for this one. And I forget what number this was. This was number 26. There we go. Alright, in 27, name an angle that's supplementary to angle COD. One of the things that really bothered me about the answers to this problem was that nobody really highlighted the angle COD, like they just left the picture blank. Highlight that angle. Supplementary means an angle that makes it add up to 180. So COD is here. So if we go through the answer choices, you can see what makes sense. Answer choice A is DOE. Look, together these two form a straight line. So guess what? A is the correct answer. Let's talk about why some of these aren't the correct answer, because a lot of people miss this one. So COD was here. AOE is here. Those are not supplementary. they're vertical, they would be congruent. If you're looking at angle BOD, BOD overlaps COD, so they can't be supplementary. BOD is 90, COD is not 90, so they clearly don't add up to 180. And then the last one was BOC. So if you look at BOC, that angle is right here. They are adjacent. They do add to 90, so these two would be complementary if I had been looking for that, but I was looking for supplementary. The only correct answer is DOE. 28, again, if these two angles are supplementary, and they add to 180, so if one of my angles is 69, I subtract that from 180, then I know that the measure of angle G has to be 111. That's what makes them add up to 180. For 29, we want to solve for x. Most incorrect answers were gotten by setting these two equal to each other, but they form a straight line, so we need to add them and set them equal to 180. So, there's your correct equation. Combine like terms. That gives me 6x plus 162 equals 180. Then we'd subtract 162 from both sides. We get 6x equals 18. Divide by 6, and we get 3. Not negative 3, that's just a scribble. We get 3. What was the question asking? For x. I don't even have to go back in and plug it in to find an angle. Just x equals 3. Here all you have to do is identify the transformation. Since I'm multiplying my x and y values, this is a dilation, and my scale factor is 3, so this would be an enlargement. Here, because I'm adding and subtracting from the x values, the type of transformation is a translation. It goes to the right 6 because I'm adding, and down 3 because I'm subtracting. In number 32, this is one of those ones you just have to know this is not a rotation. This is a reflection over the line y equals negative x. Number 33, this one was also a reflection over, let's see, if I draw a picture of it, I have xy goes to negative xy, so that's a reflection over the y-axis. Or you could have said it's a reflection over the line x equals 0. And the last one, again, we're adding or subtracting. We're only doing it to the x value, but it's still a translation. Just this time, all we're doing is going to the left 7 units. Okay, so review all those. Figure out if there's things that you still don't understand, even after going over the correct solution. And then you're going to do some additional practice problems before you can do a retake on this test.